Let's continue with chapter 20 of our test 2 review. And now we're looking at simplifying circuits with resistors in series and parallel, and also determining the potential difference or the current through any resistor and being able to work backwards. So I'll do all of these together, and this will be very similar to what we did back in chapter 18 with capacitors in series and parallel. So I'm not going to show any numbers, but I'll just draw a random circuit here and see what happens. So I have resistor here, resistor here. Let's see. Resistor here, resistor here. Alright, so let's call this R1, R2, R3, and R4. There's our voltage here. So the first thing you want to do is being able to simplify. You're going to want to draw every single step, because I may ask you for the equivalent resistance on the test, but I'll break it down into steps such as, okay, what did you get for the resistance after you simplified your first set of resistors? So first of all, we're going to identify 3 and 4 in series here. There's just one wire. The two resistors are connected. There's no junction. So you're going to redraw the circuit. We haven't touched R1 or R2, but we've simplified 3 and 4 here. So this is still 1 and 2. Then underneath, what you want to do is say, okay, how did you find this new resistance here? So because they were in series, we said that the equivalent resistance is the sum of the individual resistances. And then we do it again, and now we see that these two are in parallel. This end is connected to that end, there's a junction. This end is connected to that end, there's a junction. So we're going to draw it again. We haven't touched R1 yet, but this one here is now the combination of 2, 3, and 4. So underneath it, you want to say, well, how did you calculate this one? Well, those were in parallel, so you're going to do 1 over R2, 3, 4 is 1 over R2 plus 1 over R3, 4. And you'd have to do a little bit of math to get R2, 3, 4 by itself. And then you'd want to do the final step that says these two are in series. So now you want to simplify this. This is the final equivalent resistance. And this one would be equal to the sum of these two since they were in series. So that's the first thing that I have written up here. Identify resistors in series, find the equivalent resistance, redraw the circuit, keep repeating until you're down to 1. So on a test I might say, okay, what was the first step here? To get the equivalent resistance, you say, well, the first step will be to combine 3 and 4 in series. And then I could ask you, well, what did you get when you completed that first step? So whatever this number came out to be, that would be what you got. So it's really helpful if you really are organized and write down every step. And then you're going to be able to work backwards. So you should be able to find the potential difference across or current through any resistor. So I'm just going to ask about, let's say, R2. And what if I asked you, what is the current through R2. So you're given a delta V here, but you don't want to just do delta V over R to get the current because you'll get it wrong. You want to start at the end and find the current and the potential difference across each resistor that will help you work backwards to the one that you're interested in. We're interested in R2. So over here we have delta V, it's whatever was given. So we could find the current in this circuit and say it's delta V over R equivalent. If you do this underneath this last circuit here, then you know that you can always use whatever values that you just calculated above. You don't have to go searching for values. And then you go back a step, and we're looking at R234 because that will get us back to R2. So what do we know about R234? We already saw for R234 previously. We got some kind of number out of here. So find I and delta V. So we know that these two were in series to get this one, so this current through this one must be the same as the current through here. So we can now say that I234, the current through this resistor, is equal to whatever I that we found here. So we have I and R, so we want to calculate V. The voltage across 234 is going to be the current through 234 times the resistance of 234. So you get a number here because you have I and R. And then you work backwards again. And we care about R2, so what do we know about R2? So we don't even have to look at R34 here because I randomly asked about R2. So we already have R2 was given, and it's going to be drawn in the circuit, the value of that R2. So we have R2 already as a given, and then we need the V and I. So what do we know about R2? Well, these two were in parallel to get 234, so the voltage is the same in parallel, so you can say delta V2 is equal to the voltage that we just found here. And now that we have R and V for resistor 2, we can find I through number 2, which would be delta V2 over R2. And that would be our answer. Now, I could ask for the current or voltage across any. So if I happen to ask something about number 3 or 4, then you'd have to go back another step. Right? Let's say I asked for the current through R4, right? So back on here, we have the resistance, and we also have the voltage across 3,4, which is still the 234, right? Both of these have the same voltage. So you'd have to get the current through R34 by doing voltage 234 over R34, right? So the current through number 34 would be delta V34, which would be the same as the 234, but divided by R34. And then once you have this current through here, then you go back a step and say, okay, well, these two were in series to get here, so the current through R4 has to be the same as the current through 3,4. So I4 would be equal to I34. So I hope that helps in simplifying your circuits. And I'm going to stick to just finding current or potential difference. You're not going to have to find power through any of the resistors, even though that would just be using one additional equation for power. The process is still the same.